So in this lecture, we will be discussing about the programming of 8085. And in this, we will be discussing about the sorting of the numbers. Uh, in the previous, we have already discussed that how to sort the number in the ascending order. And in this case, we will be discussing about how to sort the number in descending order. Now, we all know that what is the meaning of ascending order and the descending order. Descending order stands for uh, in the decreasing order, meaning thereby if there are certain numbers which are given, and if it is asked to arrange these numbers in descending order, it means out of those numbers, whatever number is the highest or the biggest number, it should come first, then the second highest or the biggest, then the third highest and the biggest, and the last number should be the lowest number. So while discussing the ascending order, we have explained that if there are 10 numbers, in that case, uh, we have to use certain counters so that individual numbers can be compared all together, and we will be able to decide that which number is smaller, because in that ascending order, the smallest number should come first and the highest number should come last. But in case of descending order, the highest number should come first and the lowest number should come in the last. So uh, if there are 10 numbers, then how many comparison we have to do? We have already discussed, but right now we are again going to discuss the algorithm with which we are comparing the number is very simple, or we are sorting the number is very simple. First of all, we are going to take first two numbers and then we are going to check whether which number is greater number. Now, if we take the example of 74 and 79, if these two numbers are compared, you will be able to find that 79 is greater than 74. It means if this is the two number and it is asked to put it in the descending order, the 79 should come first and 74 should come down. But if it is ascending order, then in that case, 74 is okay with that place and 79 is okay with that place. So what we have to do in the descending order, first of all, we are going to compare the first two numbers, and uh, according to its value, the numbers are being replaced. Since 74 is smaller and 79 is greater, so we will put 79 over here and 74 over here. And then we are going to compare the second number with the third number. Now the second number will be 74, the third number is 89. Out of these two numbers, 89 is greater, so 89 will come in the place of 74 and 74 will come in place of 89 and so on. So in this way, in one round, we are going to compare individual two numbers, and accordingly, the numbers are being shifted according to their values. If they are greater, it will come up. If they are smaller, they will come down. So this is the case of one round in which we have to do 9 comparisons, because first of all, 8050 content will be compared with 8051. Then 8051 content will be compared with 8052. Then 8052 content will be compared with 53. 53 will be compared with 54 and so on. So there are 9 comparisons which are going on. But this is the round number 1. But in that case, once we are able to complete one round and individual numbers are being compared, it is not necessary that all the numbers will be sorted in the descending order. So for what we have to do again, after doing these 9 comparison in round number 1, we have to go into the round number 2. And again, we have to compare the number which is available at the subsequent memory locations. This is done just because if we are trying to find out the descending order, highest number should come first. But suppose the last number is the highest number. Then what will happen in round number 1? The last number will be coming is compared with the second last number, and it will be replaced at and will be placed at second last number. It will be not coming into the first as a first number. So that is why we have to adopt. If there are 10 numbers, we have to adopt 9 rounds, and in each round we have to do 9 comparisons. So it means there are total 9 into 9, 81 comparisons which will take place. So the flow chart says that we will initialize the counter number 1, that is representing the round by 09 because there are 10 numbers. If there are 5 numbers, then it should be replaced by 4. It means if there are n numbers, the counter will be initialized by n minus 1 value. Then we have to initialize the memory pointer because we have to locate that where the number has been placed. And in each round, we have to do comparison. So again, we have to initialize the second counter, that is counter 2, by n minus 1. Since n is equal to 10, so it will again initialize by 9. Then we will get the first number. We will increment the memory pointer. First number will be placed in accumulator and the second number will be then compared. If pointer minus one means at this time pointer has become 8051. If pointer minus 1, meaning thereby 74, is greater than pointer, means 79. If 74 is greater than 79, then we will not do anything. But since 74 is not greater than 79, so what we will do, we will interchange the content. So 79 will be coming here and 74 will be coming here. And then we will decrement the counter because first comparison has been done. We have to go for the second comparison. So first comparison has been done. So we will decrement the counter and increment the memory pointer. And then we'll check whether the counter has become 0 or not. If the counter is not 0, we will repeat the process. We will take the number, means the second number we will take, and then it will be compared by the third number. And so we will be interchanging the content or not interchanging the content depending upon whether the first number is greater than the second number or not. And this process will go on and on until unless the counter 2 becomes 0. The counter 1 was initialized, counter 2 is initialized by 09. Then it is decremented, it will become 8. Later on, it will become 7. And after that, it will become 5, 4, 3, 2, 1. And the time will come when the counter 2 will become 0. And when it will become 0, it will not repeat the process. It will go and decrement the counter number 1. Counter number 1, as I told you, that will be working as a round. So first round is over, in which all the numbers are individually compared. Then we have to go and decrement the counter and check whether the counter has become 0 or not. If it is not 0, then we will start the same process which we have adopted for the round number 1. And in this way, this process goes on. In round number 1, we will do 9 comparison. Then round number 2, we will do 9 comparison. For round number 3, we will do 9 comparison. And after all, the time will come when the counter 1 will become 0. When the counter 1 becomes 0, we will stop the process. And at that particular moment of time, whatever is the highest number that will be placed at the first place, and whatever is the smallest number that will be placed in the last place. Now the program is very much similar to the ascending order program. The only change which we have done, as you see, I have represented it by red signal, that is yes and no. In the case of ascending order, here it was no, and here it was yes. So the only change which we have to do in the ascending order program is to change this value no as yes and this value yes as no. And the same flow chart will work for the descending order. And similarly, whatever program we have written for the ascending order, it will remain as it is. The program is same. There is no change at all. Besides, it was jump on carry. Here it becomes jump on no carry. If there is no carry, it means the number is less and don't interchange. But in that case, in the case of ascending order, it was that if jump on carry. So the only change in the program which we have to do is to replace jump on carry by jump on no carry. And in the flowchart, what we have to do, we have to replace no by yes and yes by no. And that is why only one change we have to do in the programming part. So as far as the explanation of this program is concerned, I have already explained it while explaining the ascending order. The same program will be working as for the descending order. The only change we have to keep is like this. Now explanation is same as we have done in that case. Suppose the first number 8050 is 74. The second number at 8051 is 79. In the ascending order case, I have taken this example as 79 and 74, but in this case, I have changed this value. So whenever it will run, there will be a carry. And if there will be a carry, it means the first number is smaller than the second number. So this second number must be at the first place and the first number must be at the second place. So what we are going to do, we are going to interchange the value. So how this interchange process will be done? Whatever is the content of, we will be using some register D to store this value 79, and then accumulator value is transferred to the memory, that is 74 is transferred to 8051, and then memory is decremented, and then memory at whatever value we have stored at D register, it will be copied at M. It means 74 is saved or stored at 8051 and 79 is stored at 8050, and then we will going to increment the memory pointer, and then we will go on. So in this way, this particular program is going to work. The second program is to search a given byte in the list of 50 numbers. There is a series of 50 numbers which is given. What do you have to do? You have to search a given byte from that list. And wherever you find that particular number which is being compared, we have to store its memory location. Assume that byte is in the register C, and if the byte not found, we have to store 00 at 9050 and 9051. Otherwise, what we have to store, whenever the number is found, we have to store the memory location of that number. Suppose we are in search of 10. Out of that 50 numbers, I have written only 10 numbers. Out of this 50 numbers, suppose we are in search of 10. So this 10 must be present in the C register. And then once it is present in the C register, what we are going to do in this program, first of all, we will take the first number and it will copy into the accumulator. And this number is being compared by the content of the register C, that is 10. If both the number are going to match, then it's good. If the number is not going to match, meaning that by 04 is not equal to 10. So what will happen? It will skip and it will go for the next search. So we'll take the second number and compare, third number and compare. A time will come whenever we are searching, we are fetching the 10, and this 10 is being compared with 10. So it will found that 10 is matched. So 10 is matched. Whatever is the location of this 10, the location of this 10 is 8056. So 8056 must be stored at the location 9050 and 9051. And if so, if there are 50 numbers and the number which we are trying to search is not equal to 10. If it is not equal to 10, what we have to do? We have to store the 00. So whenever we find the number, whenever the number is going to match, we will store its memory location. Otherwise, what we have to do? We will store the 00 at the memory location. So how this program will work, we will first explain the flow chart of that. So the flow chart says that we will start the program. First of all, we will initialize the memory pointer, that from where the numbers are being stored, at what memory location the numbers are stored. And then we will initialize the counter. Since there are 50 numbers, 50 is a decimal number. We have to convert this 50 into a hexadecimal number so that it will be coming around 32H, because 32H is equivalent to 50 decimal. And then is pointer is equal to search byte, means we will take the first number and we'll search the number and compare with the content of C. If it is yes, then we will store the memory address. And if it is not so, what will happen? We will increment the memory pointer and decrement the counter, and then counter is not 0, we will repeat the process. So this process is repeated till the search is equal to the search byte. And if it is so, it will store the memory. Otherwise, it will store the result and it will going to stop. So how the program will function? We are in search of 10 in the given list of 50 numbers, and then how it works. So first of all, we have to load the count value in the accumulator. Count value in the no, it's not the count value. It is the memory initializing the memory pointer with the. This is the initialization of memory pointer. The explanation is not correct. It is the initialization of memory pointer from 8050 onwards. The program is written. This is wrongly written comment. I will correct it, and then we have to store the number 10 into the. Let's correct it. Now, initialize the memory pointer, then initialize C because we have to search 10 and initialize the counter as B. So first of all, what we're going to do, we will get the first number into the accumulator, and this number is being compared with the content of C. Now the content of C is 10. If both the numbers will be equal, of course, the zero flag will be set, because whenever we are going to compare two numbers and both the numbers are equal, zero flag is going to set. If zero flag is going to set, it will go to the last and it will store the memory address of that content. But if the numbers are not same, it will not jump because zero flag will not set. If the zero flag is not set, it is going to increment the memory pointer, going to decrement the counter, and it will go back. And it will going back, it will compare with the second number, and so on. It will repeat the process. At the time will come when this 10 is going to match. So in that particular case, so zero flag will be set, and whenever the zero flag is set, this is going to come into the label that is called the last, and last is SHLD 9050. SHLD is a type of instruction which is going to store the content of HL pair at 9050. Uh, Content of HL pair means H content and L. And since the memory address is stored in the HL pair register, so at L register content will be stored, the L register content will be stored at 9050, and H register content will be stored at 9051. This is the property of SHLD instruction. Of course, this has not been explained. This instruction has not been explained. We will explain it later on, but here it is being used. So you learn this instruction, how it works. SHLD means store HL pair directly to 9050. Store HL pair. Whatever is the content of HL pair, it will be stored in 9050 and 9051 consecutively. So the L register content will be stored at 9050 and H register content will be stored at 9051. And since HL pair contains the memory address, and the memory address of what? The particular value which we are fetching from the memory. So whenever we are fetching whenever we are fetching 10 from the memory, at that particular moment of time, HL pair will be loaded with 8056, because in the initial stage, HL pair will be 8051, then HL pair will become 8051, 8052, then it will become 8053. A time will come when it will become 8056 whenever it is fetching 10. And whenever 10 is being fetched, at that moment of time, HL pair will be having 8056. So when this 10 is going to be matched with the content of register, HL pair contains the 8056. So whenever this zero flag is going to set, we are going to store the HL pair content into 9050. And suppose the number which we are searching is not going to match, then in that particular case, the problem says store 00. So what we are going to do, we are going to load, because this process will go on, and the time will come, all the 50 numbers are exhausted. And when all the 50 numbers are exhausted, decrement C will become 0, and it will become 0. It will now go back. It will come to here. It means no number has been found. No number is matched. So at that time, HL pair is loaded with 000, and then SHLD 9050, and then jump end, and end is going to halt the program. So in this way, this particular program is going to work. It may be possible that the carry is being generated after adding the. That is why it is assumed that the result may be 16-bit and these 16-bit numbers. So one register will be used to store the sum and another register will be used to store the carry. So in this way it will work. Now how the program is going to work? First of all, we are going to load the counter value into the accumulator. Count value means how many numbers are there. Then we are going to load this count value into the C register. And then first memory pointer is being loaded into the HL pair. And we are using two registers, D register and E register. E register is used for storing the sum and D register is used to store the carry, and both the registers are initialized by 00. And then we are first taking the first number. So first number is stored in the accumulator. And then it is being ANDed with 01. It means we are going to mask bit 1 to bit 7 besides bit 0. Bit 1 to bit 7, because if we are doing AND operation with 01 and the D0 bit is 1, 0 flag will be going to set. And if 0 flag is being set, it means the number is not even. If this bit 1 is 1, it means the number is an odd number. And if it is an odd number, we are going to, the 0 flag will not set, and then it is going to add the lower byte into the sum, and then sum is equal to sum plus data. And then we will copy, means we are going to store the sum into the E register again. And then we will check whether there is a carry generated or not. If there is no carry, we will not increment the content of D. But if there is carry, we will do the increment process. So in this case, skip, and in this case, skip, both the cases, it will be coming over here, where we will going to increment the pointer. We are going to decrement the counter, and it will go, since the counter is not 0, it will go back. And again, it will take the second number. And then while reading the second number, it is going to check the bit D0 by doing the AND operation. One more thing, instead of using the AND operation, you can also do the right rotation process. You can use right rotation instruction in which the D0 bit will be supplied to the carry bit. And then in that case, instead of checking the 0 flag, you can check the carry flag. So let us go with the example. Suppose we have these four numbers, 9A, 52, 89, and 3F. Out of these four numbers, 9A is an even number, 52 is an even number, but 89 is an odd number, because in this case 9 represents 1001, means D0 bit is 1. But in case of 9A, bit D0 is 0, 52 bit D0 is 0, but in 89 the bit 0 is equal to 1. So this is an odd number, and when this is an odd number, this number is added with the initialized sum value, that is 00. Later on, the fourth number is 3F. 3F is again an odd number. Why it is odd number? Because D0 bit is again 1. So it means 89 will be added with 3F, and the result which will be coming will be C8, and this C8 will be stored in a register, and later on this register. Now there is no carry is generated, so carry bit will remain as 00. So at 2300 we will be storing the sum, and at 2301 we will be storing the carry. So in this way, this program is going to work.